Okay, I'm gonna make a couple of videos, and the reason for these videos is that I have a really interesting suggestion from a course that I'm involved in, and that is that I make some videos directly associated with the class. Now, this video is going to be about leasing batteries, okay? And they could be leasing batteries for a bus or something else. Now, when I make this video about leasing, I used to think wrongly because I worked on leases sometime in the 1980s, I think, that they were pretty much like loans and they were pretty simple. And of course, I was completely wrong. And the more I got into it in this class, I realized how little I know, and I hope I'm straightening this out. And the first issue is really that we want to come up with a lease rate that we think is good and accounts for the value changes over the life of a battery for this bus. And the big risk and the big thing we have to account for is what would the value of this battery be after the term of the lease, after the lease term. There's a residual value. And then once we have structured the price and come up with the price of this lease, how do we understand just how risky this residual value really is? How do we incorporate that into a model? Now, the other thing I have been working on lately is I'm surprised at how suddenly it's come up, and perhaps it's just chance. But I have gotten a few and looked at a few models with many, many, many different projects. They could be solar projects, and it's natural to have solar projects, many different projects in a portfolio group together. Now, I've made some videos about this. I've made some videos about this, but when you have these portfolios of projects, the models can become enormous, which I don't really care about, but they can also become really slow, which I really, really care about. And how do we, if we're presenting some kind of model, can we please, oh, I gotta say this, can we please remember why we're making it? We're making it so we can structure some leases, for example. We're making it so investors and lenders can understand some of the risks and understand some of the structuring issues. You're not making the model for an auditor or just to be impressive, okay? Well, hopefully you'll be impressive, whatever. So, some of the things I'm going to deal with, and I don't think I'm going to be able to make this in one video. Some people have said, keep your videos shorter. Please keep your videos shorter. Okay, I will. And this video will kind of be an introduction, and then I'm going to really delve into how we set the price of a lease when we have some residual value risk. And the next one is how do we evaluate the risks of this residual not being realized and the different possible structures we can have on a lease. And then how do we put these leases all together? Because more and more they're distributed generation, distributed batteries, smaller hydrogen projects, whatever. There are going to be a whole lot of, I think, in the future situations where you just have to put a whole bunch of projects together and start assessing the risks of those. And then once you put these together, how do you finance them? You could finance them at the SPV level. You could make them all into little SPVs. You could make intercompany loans, and the taxes could be all different. You could have one country, some of the leases, some of the projects in one country, and try to play games with the taxes and all of this kind of stuff. You know, corporate PPAs, these are PPAs where some big company wants to show they're green and they might want to buy directly from a wind project or a solar project, and they might want to get a really advantageous electricity price. If when you have these corporate PPAs, it's really very analogous to the kind of leases we're going to look at, because you have different pricing structures. They're all different ways to price. You could price per kilowatt hour, you could price on a quantity basis, you could price on a usage basis. By the way, it would all this would be analogous to different ways you might price a real estate as well. Okay, so this I'm using a kind of case study for these batteries, but it could be anything. Now, some of the Excel points, which are going to be the big points, which I really need to get to, are we want to create a database. I've showed you this before, but then we want to make absolutely sure that this template is really flexible and that it's efficient. It's not got wasted crap in there. Because there's one thing people are asking me, which I am not an expert in by any means: how can I make my model smaller and whatever, heavy, that horrible term, whatever that means, how can I make it so it operates more quickly? And if you've got a whole lot of data, if you've got a whole big gigantic amount of data, there's no magic. Don't tell me there's magic in terms of making it smaller. For these, if we start copying projects and we copy an extra, 4,000 lines per project, it's gonna get really, really big. We need to make these project by project templates that we're going to use small, and we need to make them so flexible that we can change things. Now, I formerly used the indirect function a lot, and now and I've seen people use the start sum to end, and I think this is a lot more efficient. I can't prove it, probably I should. I haven't wasted my time on that yet. But when you do, you use this whole thing, and this whole thing, whoops, you know where it comes from? It comes from Lotus used to have one sheet, and VisiCalc had one sheet, and then oh my God, when Lotus made it from one sheet to three sheets, then that was like a revolution. And when they did that from one sheet to three sheets, you wanted to sum across the three sheets. I can't remember if they allowed only three. I think they allowed only three at first. Uh, but then you could sum across the sheets, and Excel left that in. But here's the problem: if you insert an extra line, it doesn't change this number from 20 to 30. And how can we make a little macro to make sure and fix that little thing in Excel? Because it's kind of a good thing to use these days, and people are using it. Now, here's the big issue. Now I'm going to go through some structuring of uh, uh, the lease, and I'm going to go through a little bit of Excel. Okay, here's some batteries, I suppose, on top of the bus. And here is the fundamental idea, is that the present value of all the payments at the initial, you use a target IRR, in the initial lease term, plus the present value brought back to today of the residual, equals the capital expenditures. Okay, I mean, and I suppose I better, I don't let the perfect be the enemy of the good. This certainly isn't perfect. So when I'm gonna put some different cases together, and you can kind of see that you have some in with some different leases, and I don't know, I've got different lease rates here, and nothing exciting happening with that one, but we can see that we have some capex. We're going to make this lease rate so that we cover those capex and this residual value. Okay, that's not such a dramatic kind of idea, but I got really lost with this. Okay, how do we could just go around and around and say our renewal is a function of our initial lease rate, and it was really hard. How do we get this value of the renewal of the lease? And if you really think about it, you think about, okay, we've got this battery here, and this battery is going to degrade. It's going to degrade like me. Oh, my mind. If you'd sell me right now, my value would be very low because I've degraded so much. Okay? That is not very funny. Sorry. And it's true though. And so it depends on how much the value you have at this residual, or I call it the renewal, it doesn't really matter, depends on how much degradation we've had so far. Now, if you would sell me and they'd say, okay, what's an old man worth anymore? They would see how much I've degraded over time and then say, okay, we know how much you've degraded. We're not going to worry about what the future is right now. But at least we could see what the value is based on what's happened in the past. And it's the same thing. I could become obsolete, which I am. Okay. I don't, invest in whatever those cryptocurrencies are. I'm obsolete. I still have old ideas. And uh, uh, if there's a new person who you can buy a lot cheaper than me, we've got it. We can look at how much obsolescence have I incurred over my term up to now. And I can also say, well, my value at least goes up with inflation, which I haven't been able to cover inflation at all, but that's a different story. Okay, and then there could be more competition. There could be a much bigger supply when this residual value happens. So what should we do? Well, you could go and try to make a forecast of what the value of batteries would be in 5 years, but what you can really do is you can come up with a formula, and this formula we're gonna use a PMT formula, and we're gonna come up with the value of this renewal. And here's how I suggest doing it. And I'm not sure this is perfect, and I'm sure it isn't quite perfect, but I've gone around and around. The first thing is to get a flat nominal lease over the entire life. Now, if we look at the life of a battery depends on how many charges you have. And if people use the battery more in the lease term, the life can be longer or the life can be shorter. So that presents a kind of interesting issue. What happens to the life? But if we could just forget the residual value, have the value of of a flat nominal payment over the entire life, then once you get this flat nominal payment over the entire life, here's what you could do. You could say, okay, well, I'm going to first figure out how much remaining life I have, again, based on the number of cycles, not the number of years. And then you can say, well, okay, let's say that the forget all of this obsolescence, degradation, inflation, and all of that stuff. For right now, let's just say that over the remaining time period, if we use this same IRR, we can figure out what a simple residual value would be. And then we can adjust that residual value for what's happened to degradation, cycles, all of that stuff. And that's what I'm really going to show you. Okay, so again, I'm repeating here a little bit that this is what drives the lease rate. Now, if let's start my suggestion here, and I've put this in a file, and if you're studying leases, I think it might be worth it, maybe not. And maybe you have some other opinions. If you do, you won't tell me. Nobody ever tells me. And I started with a extremely simple situation. So I'm going to put 0 as my target IR. Now, I just changed the generic macro. If you put reset, and I have nine little things on the top, what's going to happen? I think you can define when you want the black thing. I put it after the inputs. I thought maybe I didn't. Okay, let's put a 0 IRR, and these are inputs, so it's really bad what I did here, and I'm going to put 0 degradation. Now, if I have this simple thing, and I just paid 1,000, I remember one person in my class once said, "Oh, don't use 1,000 all the time." Why not? Okay, if we have 10 years and 1,000, if we collect 100 over the life, we'll get 0 IRRs. And the PMT formula, which this formula text is going to be a theme later on, is really important. That would give us just a flat all lease rate. And then if I have a lease term of, let's say, 4, that means the remaining term is 6. Well, I can just pay I can just figure out what a level payment over the entire lease is. Okay, and then what I can do is once I have this payment over the life of the lease, I can take the present value. I put a little formula text here as well. The present value of this lease, which at 0% is just the sum of the residual. That's with 6 more payments. And then I've got this residual. Now, it's a really big deal for me, for you or me. I don't really care how they're going to structure this lease in the future. And I can get my IRR either by uh, uh, either by assuming that we have a second lease that's at the same rate because I haven't put any inflation, any degradation, anything else in, or I can just assume that the first lease gets sold. And when I do both of them, it gives me my 0 IRR. Now, if I put 10% IRR here, then I get a higher lease rate because I've got to cover my costs, and I use a PMT function. And then when I have this this flat lease over the entire term, I can compute the present value, this PV. PMT and PV are really helpful little things here. We'll get away from them when we have changing rates in a little while, but they're a really good thing to start. Now, let's see what I had in my little thing here. Okay, and then so right now I'm going to start by putting some. Well, the first thing I'm going to do is put the 10% in, and then I'm going to put some degradation in here. And if you get a battery today, now there's a really the degradation should include the expected degradation or the as well as the past degradation. And it's true, and I don't have that really modeled right now. And one of the things to really understand about these things is that there are some variables like obsolescence, inflation, they depend on calendar years. They depend on exogenous, external kind of things. Degradation could have a curve. We'll get into that here. Here, this is who Tesla said that how much it's going to degrade, and it degrades a little bit differently over the first few years than the last years, and we're going to incorporate all of that, and we get very different numbers over 10 years than 5 years, and you can take 1 plus the degradation rate minus the degradation rate to raise the 10th power or the 15th power to back in the annual degradation. And then we're going to put those in our model. And we're also going to account for obsolescence, which is the fact that battery prices might come down. There's our most famous ever battery thing from Bloomberg, okay? And let's just work through that just a little bit here. Okay, so I'm showing you this. Uh, uh, so let's say right now we have no degradation. That's the one I started to say. And if I put this 708 here as my residual value, you notice how we should always kind of hopefully be very transparent as when where you're getting this. You could either put this flat lease rate in over the whole tenor of the lease, or you could put a residual value. And for me, this is where to start. Start with a simple example. Don't go crazy. I was screaming about this the other day. So I said, please, please, if you don't understand some tax thing, get a simple example. I really believe that. Okay. Now let's put some degradation. If I have, let's put 5% degradation. That's enormous. So we could take this present value, and then we can say, oh, I'm going to take that. I'm going to take that degradation and let's put the lease rate to be the term to be 6. So over the first, we're going to grow the decline, really, the degradation by 5% per year. And that means that the value of our renewal, which was without the degradation, which was 700, whoops, just a minute. Okay, come on. I told you I'm degrading. Without the renewal, the value here that we put in, and our residual value is 515. If I put 5% degradation in here, my value goes down to 319 because the person who's going to buy this new battery or lease this new battery is going to get a battery that has a lot less power output. And the power output, I'm just going to raise this to that power. And if I do that, let's do that one more time. If I do that, then look at the initial lease rate. The initial lease rate here is 162, and when I put the 5% in, it has to go up to 180. It's got to cover the fact that my residual value is going to be less. If I put 10%, then the lease rate has to go up to 194. Okay, that's the risk of the risk of the degradation. And you notice what I did here is this is the amount that happened over the first years of the life. Now, again, this is the if other batteries are going to go down and you're going to have this learning rate, this is what Bloomberg calls it because they love this stuff, and they said there's an 18% learning rate. That means if that's an annual rate, which is enormous, I don't think it's an annual rate, but okay. If it would be annual rate, kind of like solar, that means that the value of your project, and this relates exactly to corporate PPAs, it relates to whatever, a real estate, what happens, you have to predict, basically, you have to predict what the market is going to be. It's like predicting, well, it's not really like predicting merchant prices. It's predicting that if you can buy a new solar project in year 10 for much less, I don't care how much you have made a forecast about your uh, um, merchant prices. Somebody can buy a solar project for a lot less. That's going to affect the value of your project going forward. I'm sorry. And that learning rate is dangerous. So what happens? Let's put 0 here, and let's put this 18%, which is ridiculous. That means the value of the residual went way, way down. And it's the same sort of formula as there was 515 here, and then we put 18%. And that's an enormous risk, isn't it? That we'll have a really big change in value from obsolescence. And now let's make it more reasonable. Let's put 5% and 7%. And now we have to charge a higher lease rate. And we can either, once we get this key thing, and once we get this value of the residual, we can put a new lease rate in. Who really cares about that? And then we can also put in the residual, and it absolutely doesn't matter what you do. Now, if you have an offset, if you put 2% inflation, then it goes up because we've made a completely nominal lease, and we really should have always accounted for inflation. If I put a zero. This is what I've been belaboring too much, but if I put inflation in here, we can get 154 for our initial lease. Let's put a 4 initial lease. And if you're trying to explain this to somebody, I would try to do something like this. So without inflation, we get 162. With inflation, we can give you a lower upfront lease because we're going to get a higher nominal value of a residual. And of course, this IRR is really that's supposed to be a nominal IRR. So when we finally do the analysis, we really want to look at what the real IRR is after inflation and the nominal IRR. So that's how we take this number and start adjusting it for inflation. Now, I mean, for the risks. And then when you do now, once you have these things in, then we're going to structure the pricing of the lease. But I'm gonna make that the second part of the video. Before I make that second part of the video, once you have a simple kind of model, let's convert that to a more realistic and complicated kind of model. Not that complicated, but I'm now assuming that we have 22 different projects. And I call them, we can put names for these projects, but for now I'm just calling them Project 1, Project 2. You can do whatever you want. I think it might be a good idea we're going to make a separate spreadsheet with them all, but this time we have different start dates. We could put different IRRs in to get this, and I'm going to suggest very, very strongly that if you have different projects that could go in at different times, you want to do this monthly, maybe daily, but oh God, I don't want to even think about that. Okay, and when we do things monthly, please, I'm not crying so much, but you don't have to be don't use the XIRR. Just take one plus the IRR, raise it to the 1/12th, blah blah blah, and then we can all our projects can have different lease terms, and then when we put in our end of the lease, you need to put a -1 in, and I'm only using one date. I'm trying to be a little efficient. And our battery can have some capacity and some energy, and that gives us a duration, which isn't really hours, but it's kind of like hours. And then we can see how many cycles per year we have. Now, if we run the battery, if we give our battery to this bus driver, the buses, and they run it a lot more, a lot less, then the problem is that we have the life of our project really expressed in cycles, not in years. And that gives us a total life. If we take the cycles divided by the cycles per year, is that right? Press F2 and you get that many months, and then you can figure out the remaining life. And remember that remaining life is a big deal in the valuation of the lease. And then for the cost, well, I made a little formula where I adjusted the cost based on the amount of capacity and energy because they're both accounted for. So we get the capital expenditures, just like I showed you. And then once we get this, now we're going to, instead of having uh, uh, I just realized I had something wrong. I'm not going to touch these right now. We have the predicted degradation, and we have to predict the degradation, predict the inflation, predict the obsolescence and the learning, and then we're going to know all of our predictions are going to be wrong, and that's where the risk comes in, and the risk can come in either in terms of the way we structure the lease, because we could have a lease that is a price per unit per kilowatt hour. We could have a lease that has inflation built in. We could have a lease that's just got a flat payment that doesn't have inflation. We're going to work through all of the different possible, not all of them, but at least four of them, of the different lease payments. Now, once we have this, the way we'll set up a model is, and I've done this too much, I'm not going to go through all this. I just put in a month by month, a timeline that's a completely generic timeline. That's step one. And then you just put in your project, and this is the absolute key, is you take this project name and you make a match function and you match it against all of the whole line. Don't, please, oh, I'm going to cry about this again, but please, I wonder how many people really do this. I've tried to prove it again and again. If you think your model is going to get really big because you use the whole line, that's ridiculous. And if you put a comma zero in, actually, my friend Thomas said, okay, the match zero takes more time than the match one because it's got to do a little more work. And he's right. God, is he smart. And then I put in the development, and every time we do this, we just go to the line number. The line number 7 is when we start our whole thing, and we have an index. We go to that line number. And then the next one has one for the next number, and so on and so forth. Well, not all of them, okay? And we use the index for a whole bunch of things. That's an output. And then we get now this time what I did is when I ran the generic macros, I put this reverse font in here so we can really highlight these more strongly. I don't care. I don't know if you care about this. So the first thing I said is, let's get the flat payment over the whole life. And to get the flat payment, just like we did with this one, we just started with a flat payment, and we just said, okay, let's take the PMT over the entire life. And that life depends on the number of cycles, which will get a little more interesting and a little tougher. And then we can say, okay, let's make sure that let's compute the IRR on I need to do this, and let me put project one in here so we can see our CapEx. Here's our CapEx. And of course, we get our target IRR. And then we say, no, let's look at the residual. And this time we put it in months, not a big deal. And we'll get the present value. This is our kind of unadjusted thing. It's the same thing over the entire life. Nothing new here. This is the unadjusted amount. And then it gets a little trickier. Then I take this green stuff, and this green stuff use a lookup. Now, if you would need to have these things on a lease by lease by lease by lease basis, you would have to stick these into the template model, and that template model would get bigger, and maybe you'd have to do that. I'm not saying you wouldn't have to do that, but if one lease is going to use a code number 1, which is different than a base case and all that, and of course I made an index function, and then I took the growth rate and raise it to the 1 divided by 12 power minus 1. You should always do all this stuff on a monthly basis, okay? Once we have that, where am I? Okay, we're here. Then we plop this in, and what we need to do is, as I put some of these things in my input S, some of them are a function of the age of the battery, and some of them are a function of the calendar year. And this obsolescence I made by age, and I really probably should have put that by year. Sorry about that. Okay, but then you put all your month by month inflations in, you compute your indices, the degradation is going down, the the obsolescence is going down, and the inflation is going up. And then here's the trick. Here's the trick, and I didn't know how to do this at first. Once you get the accumulated you get the accumulated why did it stop here? Just a minute. You get the accumulated, that's because of my generic macros. You can adjust that. The accumulated amount of degradation at the end of the lease, the accumulated amount of obsolescence, the accumulated inflation rate at the end of this. You press, and you can use a lookup function and say, I'm just going to look up on this number and I'm going to find the date and then go down and get it. Okay, that's what happened here. Okay, and that's that one. I don't know why that's happening. Okay, probably something I did. And then we have the same thing for the other one. Now, just to skip ahead, if I use a case that has a higher degradation, no, that's actual degradation. Let's not go there yet. Okay, we could put a different expected degradation in here. This is when we're structuring our lease. We don't know what the actual is yet. That's a risk we have to take. We don't know what the actual obsolescence is, but we've got to put something in. We can't get around that. And then we finally accumulate all these things just by multiplying them together. These are all our factors, and we take this amount that we started with, and we get the we get the reduction. And I don't know what's happening here, why it's showing. So our residual value, if we didn't have any of those factors that reduced it, would be this, but we get a lower amount. Okay, and then we take the total capital expenditures that we had all the way at the beginning, and we subtract how much residual value we have, and guess what? We can use our PMT function to get the to get the renewal, no, to get the original lease rate. Now, when you do all of this, I'm skipping a little down here. If we put this lease rate in and just made the lease rate flat down here, we get a present value of the lease and we get an IRR exactly of our 5%. Okay, so that's just a little more complicated things. I think the best thing to do here is to allow you to really work through the model. So that's part number one. Part number two, which I'm going to do right now, is going to be on risk analysis of this lease. Part number three is going to be putting this together in a portfolio. And part number four, which I might not quite get to, is going to be financing this whole thing, financing this either at the SPV level or the